Hello. Welcome to my YouTube channel. You're very much welcome. I'm your host, David Chirikwa. Without wasting much of our time, today we are going to look at, in this video, we are going to look at solving equations of the form a sine theta plus b cos theta is equal to c. So we can see when you look at this title, this simply symbolizes that we are going to look at something, a subtopic of part of trigonometric equations. Please don't forget this topic applies to those who are doing first year, A-level, IGCSE, AS and A-level, and additional mathematics, like in O-level, additional mathematics for ECZ. This is in the syllabus. Therefore, this topic, this subtopic is catering a variety of syllabi, which I've just stated earlier on. So now I'm going to read the question, then you get through to the solution. Example: express 3 cos x minus square root of 17 sin x in the form r cos. So now r cos x plus alpha, where r is equal to 0, hence solve the equation. So we are going to see that most of the questions, this is how they will be coming, because you cannot solve this question without or minus you having to express this question or this function in this form. So that's why these will be following up each other. If this part, where there is not, this question is not there, you find that they will ask you about the maximum value of this particular function, the maximum or the minimum value. So you can see that these questions, they are in uniformity. This is pure mathematics. Therefore, they've got ways and means in which you can work them out. So let us get to it. Solution for 1. So first thing I'm going to do is to write 3 cos x minus square root of 7 sine x. This must be equal to r cos x plus alpha. So we are going to maintain the left-hand side, so it will be 3 cos x minus square root of 7 sine x. This is going to be equal to r, open brackets, using the cosine identities. So this would be cos x cos alpha, since here is plus minus sine x sine alpha. Maintaining the left hand side, we have square root of 17 sine x will be equal to r times cos x cos alpha minus r sine x sine alpha. So having done this, the next thing we do is we equate the terms which have got cos x and also the terms which have got sine x. So this will be now 3 cos x is equal to r cos x cos alpha and negative root of 7 sine x is equal to sine x sine alpha. So from there, what are we going to have? It means that we can divide by cos x by cos x. So we remain with 3 is equal to r cos alpha, and this becomes our equation 1. And this side we also divide by sine x sine divides, remain with negative root of 7 is equal to sine alpha. And this becomes our equation 2. So having done this, now we divide equation 2 by equation 1. So what are we going to have? We are going to have r sine alpha divided by r cos alpha. This is equal to, on the other side again, we divide square root of 7 by 3. The idea here is to make tan, because this is the tan function identity. So this will be tan alpha is equal to square root of 7 over 3. So alpha will be equal to tan inverse of root of 7 over 3. So tan inverse of this, we are going to get 56. Just take one calculator. 56.7891, rounding it off correct to one decimal place, it will be 56.8 degrees. So you can see that now we have found alpha angle, which is 56.8. The next thing we do is we square. We square equation 1 and equation 2. So squaring, no, you will notice whatever you do on one side should be done on the other side. So this gives us 9 is equal to r squared sine squared alpha. So you're supposed to have cos. Sorry for that error. Cos. Then here we are going to, when we square this, we are going to have 7 is equal to r squared sine squared x. Having done this, then we add equation 1 and equation 2, of which we get r squared cos squared alpha plus r squared sine squared alpha is equal to 9 plus 7. So this, we factor out r squared, remain with cos squared alpha plus sine squared alpha is equal to 16. This is a trig identity, which is equivalent to 1. 1 times r squared is r squared is equal to 16. So we look for the square root. Square root, our r becomes 4. Therefore, in this case, we now express in terms of what we have been asked to do. So this results to, what is our r? Our r is 4 cos x plus, we have 56.8 degrees. So that means part A we are done. Then we go to part B, where we will ask that we work out the equation, this one. Equal to 2. So, dear viewers, you can see that this function here has already been found. It is what? 4 cos x plus 56.8 is equal to 2. So what do we do next? We divide both sides by 4. Then we get cos x plus 56.8. This must give us 1/2. So now this reduces into a quadratic equation. Now, for the fact that cos this angle is equal to half, it means that this is positive. It means that we are going to go in the quadrants in which cosine is positive. And those quadrants are the quadrant 1 and quadrant 4. So, without wasting much of our time, we rewrite this as x plus 56.8 is equal to cos inverse of 1/2, which is x plus 56.8. This is equal to 60. Cos inverse of half is 60. So finding the value of x, already we can see that this is lying in the first quadrant. So 60 minus 56.8, we are going to get 3.2 degrees. Now, going in the third quadrant, we can see that we can find an angle which is now 360 degrees. Take away 60. This gives us 300 degrees. So again, using the same function, which is x plus 56.8 is equal to 300 degrees. From there, we're going to find x is equal to 300, take away 56.8 degrees. So when we subtract, the difference here is going to be 243.2 degrees. Therefore, the value of x must be equal to 3.2 degrees and 243.2 degrees. When you look at these two answers, these two angles, they are lying between 0 and 360 degrees. So this is pretty much on how we work out this type of questions in an exam. Thank you for watching, and I hope this video has been helpful to those who have been having challenges with questions like this one. Thank you so much for watching and for your support. I really appreciate it. Thank you, thank you, thank you.